Hello, this is Dr. Christy Patton-Lukes, a chemical engineering professor at Missouri S&T. In this lesson for engineering economics, we'll be looking at how we can compare equipment alternatives when the lives of the equipment are unequal. And we'll be doing this using the common denominator method. So if you've started forgetting your notation, we have just a quick look at what the notation is that we're using in this chapter. But here, so in a previous lesson, we considered comparing equipment when we had equal lives, and we could do that using a simple net present value comparison. But if the lives aren't the same, what do we do then? The NPV value isn't going to make any sense because I'll have finished one project and the other one's still going on, and so I have no equipment. That's illogical. So there are three methods that can be used to evaluate alternative equipment when the lives are not the same. In the textbook, they cover the capitalized cost method. We will not be looking at that one. But there's also the common denominator method and the equivalent annual operating cost method. In this lesson, we will be looking at the common denominator method. In the future lesson, we'll be doing the EAOC method. Now, the ranking of alternatives should not depend upon the method used to make the evaluation. The common denominator method basically is a way of comparing things for the same number of years. And so if we have two projects and one has N number of years life and one has M number of years life, you're going to have to keep replacing them until you can get the two to kind of quit working at the same time. Turns out that if you replace the one with a life of N years, M times, and the one with a life of M years, N times, you end up with essentially a common denominator, and that will allow you to put them on an equal time footing. But now what this means is that every N years, I'm going to have to purchase an additional piece of equipment. And I may have salvage values associated with that, but the annual operating cost will continue throughout. So even in these years I'm making purchases, I will also have my annual operating costs. So let's look at a fairly simple problem where I have an initial cost and an annual benefit. So maybe I'm using it to manufacture something and I can manufacture exactly the same number. So the annual benefit for both is $400. But option A costs $1,500 and lasts 6 years. Option B costs $900 and only lasts 3 years. Which option should I select if I'm using a hurdle rate or an interest rate of 12%? So here I have one can last 6 years and one can last 3 years. So the common denominator between these two numbers is 6. So this one I'll only have to purchase and, take it through its entire life. This one I'll purchase and after 3 years I'll have to replace it. So let's first analyze option A. I just simply need to determine the present value. So first I spend $1,500 and then I accrue a benefit of $400 per year. So I want to take this annuity to the present at a 12% interest rate for 6 years. And when you do the numbers on this, it comes out that it's going to give you a net positive present value of $145. Option B needs to be replaced at the end of year 3. So to do that present value, I'm going to have the initial purchase price in year 0, at the beginning of year 1. And then at the 3rd year, I'm going to have to purchase a new one and bring that future value back to the present 3 years. Of course, I still have that annuity for my annual benefit. Running these numbers, the net benefit is $104. So which option should we choose? The one with the largest value, obviously. In this case, they're both positive, so therefore our choice is option A. Let's look at another example. So this time I can choose either A or B. A is going to cost $5,300. Strike that last sentence there, and this, I forgot to erase it from the previous slide. So $5,300 for A, it'll create a savings of $1,800 per year. And at the end of life, I can salvage this for $500. But the lifespan is only 2 years. Option B is going to cost twice as much almost, $10,700. Annual savings is $2,100. Salvage value is $800, but this one will last 5 years. We're again going to be using a hurdle rate of 12%. So here my common denominator between 2 and 5 is 10 years, meaning that for option A, I'll need to repurchase this item 5 different times. The net present value, therefore, I purchase the first one. In 2 years, I purchase another one, but I get a salvage value for the first one, but it's 2 years later. 4 years later, I'm going to purchase yet another one, get the salvage value from the second one, then purchase a fourth one, salvage on the third one, purchase a fifth one, salvage the fourth one, and then finally in the final year I'll salvage the final one. In the meantime, all of those 10 years I've had this annual savings of $1,800. And with this I find a net present value of that this will cost me negative $6,377. Now option B, I only have to repurchase this one twice. So at the end of 5 years, at the end of 10 years. So I've got my initial purchase, my second purchase, I salvage the first one, I salvage the second one. I have my operating savings figured here, and this one has a net present value of negative $4,194. Which one do I want to choose? The lower cost one is option B. So this is one way that is somewhat logical but a very cumbersome approach to comparing items with different operating lives. In our next lesson, we'll be looking at another method that I find simpler to do the calculations, but perhaps not as intuitive why it is the same. But we will be looking at these same examples to see that the other technique gets identical answers. Thank you very much for your time.